All right, lesson 11B, we're going to talk about a t-test for two means, okay? And these are small independent samples. So our two samples are taken independent of each other, okay? And just like our last lesson, when we use this is when both sample sizes are small, so n is less than 30, and one or both population standard deviations are unknown, okay? So if we know only one of them, we have to use a t-test. If we know both population standard deviations, then we would be using a z-test, okay? All right, so here's our steps. Very similar to what we've been doing, write the null and alternative hypothesis. Right, and just like we did with our z-test for two means, we're going to assume that there's no difference between the means. So our null hypothesis is always going to be that mean 1, u1 minus mu2 is equal to 0. Identify the level of significance from the problem, okay? And then we're still using our calculator to perform the t-test and get the p-value. Okay, this time we're going to choose a two-sample test and then enter our data. Same as before, we reject or fail to reject the null hypothesis based on the p-value compared to alpha. So if p is less than alpha, we reject. P is greater than alpha, we fail to reject. And then we write our one-sentence conclusion. All right, so here's our example. We have SOL results for two different teachers, okay, and we want to see, can we conclude there is a difference in the mean scores of the two groups? Alpha is 0.10. This is important for how we put things in the calculator, so the problem will tell you if the population variances are equal or not equal. Okay, so when they are not equal, we go to put stuff in our calculator, at the end there's an option that says pooled. Okay, if they are not equal, we turn the pooled off. If the problem tells you that the population variances are equal, then we would turn pooled on. Okay, so teacher 1, we have mean standard deviation sample size. Teacher 2, we have mean standard deviation sample size. So let me grab my calculator. All right, and same as before, we're going menu, stat, okay, F3 for test, F2 for T, and this time we're doing a two sample, so F2. All right, we want variable because we're not putting our stuff in a list. Okay, what are we testing? Okay, can you conclude there is a difference in the mean score? So let's write our hypotheses. So my null hypothesis, okay, would be that the difference between mean 1 and mean 2 is 0. Okay, that's always my null hypothesis. I assume that the two are the same. My alternative hypothesis, all right, is that mean 1 minus mean 2. All the question says is, can we conclude there is a difference? All right, the question doesn't want us to say, you know, teacher 1 was better than teacher 2. It's just saying, is there a difference between the two? So our alternative hypothesis is that the difference between the means is not 0. Okay, it could be anything, but if it's not 0, then that means there is a difference. Okay, so my alternative hypothesis being tested is that mean 1 does not equal mean 2. Okay, and then I can type in x1, and it's just the sample data. So for each sample, so the mean was 473 for the first teacher. The standard deviation was 39.7 for the first teacher, and the sample size was 8. All right, mean for teacher number 2 was 459. Our standard deviation was 24.5, and our sample size was 18. Okay, assume the population variances are not equal. So not equal, we want pooled to be off. And then I can press enter one more time to get my results. So here's my p-value, 0.379. All right, so p is equal to 0.379. Okay, so just like same hypothesis testing procedure that we did for multiple units, okay? P is 0.379. That is greater than alpha, all right, because my alpha is 0.10. So in this case, I would fail to reject, the null hypothesis. So I cannot conclude that there is a difference in the mean scores, all right, because I failed to reject my null hypothesis. Okay, so the big thing here is we're just typing in data, all right, mu1 is your alternative hypothesis, so it's equal, either greater than, less than, or not equal to, and then pay attention to the pooled part. Okay, when population variances are not equal, pooled is off. If the problem tells you that they are equal, pooled is on, and that information will always be given to you in the problem. All right, and that is it for difference between two means t-tests.